Good morning and welcome to the ETSI virtual event on boosting the impact of research and innovation through standardization. I'm Guy Daniels, and in this session we will be looking at graph structured data for real-world scenarios. And to explain more, I am joined by Lindsay Frost, Chairman of ETSI ISG CIM, and Bhushan Kotnis, AI Research Lead, NEC Labs Europe. Welcome both of you. Thanks very much for taking part today. Lindsay, if you would like to start the presentation, and then we'll hear from Bhushan and follow up with a discussion between the three of us. So, Lindsay, over to you.
Thank you very much. So, first of all, I note that most of my time is spent supporting ETSI in the ISG CIM group, that is for Context Information Management, and at the ETSI board, and recently also as chairman of the Oversight and Coordination Group for Artificial Intelligence in ETSI, and that work is supported by NEC. So I'll be talking about the standard side and what is being done inside ETSI related to graph structured data. So in the overview I'm showing now, it's an example of a real-world scenario for a complex case such as a smart city, and the city picture that you see is decomposed or analyzed, or let's say information is collected according to all kinds of entities which are in the city, so buildings, radio towers, people, cars, whatever the use case requires. And each of those entities has got, of course, different properties or characteristics like location, or in the case of cars, the speed. In the case of buildings, maybe the building address, and so on. And these data are used by different applications, as you are all well aware. And on top of that usual description, there are not just those the properties of the entities, but also the relationships between the different entities. So a car is owned by somebody, or somebody lives at a certain a building or address. And these relationships, as we all know, they change all the time and are very important for real-world use cases. So what we tried to do in ETSI, in the Industry Specification Group for Context Information Management, over the last year or two, is create a flexible and rather easy to use protocol to send information from sensors, from mobile apps, from databases of maybe the city government into other applications so that they can be reused. And we're trying to take care also of issues like GDPR and quality of data and, of course, security. So in a way, we're trying to link up the information about each object as is needed and as permissions are given. So not only that, of course, in many cases there are complicated databases, complicated web servers with videos. We provide a way to link to that kind of information, but we try not to do everything. So we try to keep things simple. And in the spirit of keeping things simple, there's an example at the link shown on this page of a grocery store with certain products and certain shelving and certain customers, to show in the example on the web how the protocol can be used to transmit information as it's collected, or to query the already available information to discover if the product is getting near to end of stock, or if the store is maybe overfilled with customers. It needs to have a bit more. In Corona times, has to be a bit more advertising to come back later. And that kind of information can be sent in small packages or messages, and a little example is given in green on the right. Don't try to read it right now. If you're interested, it's based on programming language that people know called JSON, in particular JSON-LD. LD stands for linked data. And particularly, we try that the information which is shuttled back and forth between the source of the information, like a sensor or a database, and the application needing it, that this information is also tagged with the unique identifier of not only the entity, but also what does it mean if we say that the temperature is, let's say for some cool product, temperature is maybe 4 degrees. Now, obviously 4 degrees in Europe is quite different to 4 degrees in America, and you need to keep track for global or other applications what kind of standards or what kind of calibration is behind all of the different measurements or different data that you collect. And that's very important in the next talk as well. So keep in mind, in NGSI-LD, we have ways that you can record not just the name of something, but what that name means, what the definition behind it is, and of course, the quality and the source of that information. So in the way that it's collected is in a way which is looking in terms of properties and entities and relationships, a little bit like on the right-hand side of this picture. And I do not want to go into detail except to say that we can easily add new relationships and new properties and new entities all the time. So that's, again, very important. If you go back to the smart city example, maybe you set up something where parking sensors are the first thing to come online, but then the city installs maybe measurement of noise pollution or other, let's say, pollution from vehicles and so on. And those sensors need completely different data structure, but it's easy to add it. You're not limited. So moving along, because of time today, I want to show that on this picture, the central image where the context information system is shown as a square box, that is not meant to say that you must have a central server. We've designed the whole system like the internet so that you can have different sources and different consumers of information all around, and they can be distributed, they can be federated, and you're not limited so that, for example, a city might have a fire department which has their information sources and data, and hospitals, and it might be that the fire department will share to the hospitals so the hospitals can get an alert to be ready for burn victims or other situations. So it can be quite separate and federated. And it sits on top of the 1M2M style of IoT infrastructure, or on top of other IoT Internet of Things infrastructures which provide data, or it gathers information from, on the left of the page, from the mobile apps or from legacy systems. So the idea is to collect, share, publish, and make it available according to usage rights to applications, including AI systems. And on the next page, I'm showing how some simple messages can be moved around. We don't need to look at them in detail. As I mentioned before, it's one of the more popular computing languages, adapted slightly for our case, and its main constraints are to make sure that people are using terms which are clearly defined and can be reused. So we really want that information is not lost in translation, and the temperature on one application is interpreted correctly on the next one. And for health records, and so here in a few minutes, that's very important. So in turning over now to Bhushan, a colleague of mine at NEC Labs in Heidelberg, I just want to emphasize collecting the information and making it available is, let's say, a very essential part of the story, and making sure the information is labeled with the owner or with the quality or with other essential properties is very important. But then comes the question, what do you do with it besides looking at parking meters? So I'd like to hand over now to Bhushan to explain some more advanced applications of graphed data. Thank you.
Thanks a lot, Lindsay. My name is Bhushan Kotnis, and I am an AI research lead at NEC Labs Europe. And today I'll be speaking on complex queries on graph structured data. As Lindsay explained, a knowledge graph contains entities and relations which connect entities. So this is an example of a knowledge graph which represents how drugs interact with each other, how drugs interact with proteins, proteins interacting with genes, and finally, how drugs may cause side effects. So essentially, what we show here is what we model here essentially is how drugs, when taken together or taken just one by one, can actually create side effects, and how it is important to model this interaction, particularly in health applications. So this, as Lindsay mentioned, one part is just gathering the data. So the first part is essentially gathering the data to create this knowledge graph. But the real magic of artificial intelligence is its ability to predict new knowledge or infer new knowledge from the knowledge we already have. So in this slide, for example, we see that, let's say drug 1 causes electrolytic shock as a side effect, while drug 3 causes nausea. And the question to be asked is, can drug 2 also cause electrolytic shock? Or maybe the question is, if drug 2 and drug 3 are taken together, can both of them cause a side effect like electrolytic shock? And this is where AI and machine learning comes into the picture. So the statistical machine learning system, which we have developed, essentially mines a bunch of statistical rules which can predict whether a particular link exists between, let's say, the entity electrolytic shock and a particular drug. And this is done by looking at the context of these entities. For example, in this case, we can see that drug 2 and drug 1 both both activate rather a particular protein, P80217, and this perhaps suggests that perhaps both of drugs may be involved in similar biological pathways, which might result in similar side effects. Similarly, AI systems can also allow us to predict that if drug 2 and drug 3 are taken together, can they actually result in electrolytic shock? So generally, in the biomedical community, it is known that if I take drug 1, a particular drug, these are the side effects this drug might cause. But it is not always known whether if I take both these two drugs together, then what sort of side effects can be expected. And this is something where AI and machine learning can play a huge part. So a knowledge graph assembles all information about how drugs interact with proteins and genes and all other biological processes. And using statistical-based machine learning rules, one could actually enable us to predict that if particular two drugs are taken together, then what sort of side effects can be expected. So in this particular case, let us look at a real world example. Let's say this is a hospital setting, and we actually want to apply a knowledge graph based AI system in a hospital setting. So let's say we have a particular patient, and a particular patient is on a particular medication. And let's say that the patient is experiencing also some symptoms like nausea, and maybe the drug itself, that is a side effect of the drug itself. The patient is associated with certain vitals, such as high blood pressure, maybe an enlarged heart, or maybe other such vitals, such as blood count, the red blood cells, and so on. And so the question could be asked as so let's say the hospital has not just one patient, but it has a bunch of patients, and it has a history of patients and their symptoms. And let's say we have inputted all of that information into a knowledge graph. So the natural question for a doctor to ask is, should patient 101 be also given given drug 2? Given the past history of the drug, especially with regard to the observations in different patients and so on. So let's say we know that patient 101 has a similar vitals. For example, the patient 101 also has a high blood pressure. Maybe the patient is also suffering from some lung diseases such as COPD, and he's already on some other drug or medication, drug 3, and already has symptoms such as arrhythmia. So the question is, should patient 101 be given the following drug? And this is exactly how we map this question to a link prediction task, where the machine learning model essentially takes this complex query. For example, it needs to resolve two things. So one is that whether the drug can actually help alleviate the patient's symptom. That is the first query. And along with that, it needs to also have a constraint that when drug 2 is taken with drug 3, it should not cause a side effect. So this is a classic example of a complex query. I would like to again stress here that this particular information as to whether the new drug will actually help the patient or whether the new drug combined with drug 3 will actually cause a side effect or not in that patient is actually not known. We actually don't know. The value is not there in the knowledge graph. It's not there in the database. And this is really where the artificial intelligence comes into the picture. That it allows one to predict these things even without without even being these values being there in the knowledge graph, but it allows us to predict them given the entire context and given the entire knowledge graph. So essentially here we can actually predict whether patient 101 can take drug 2 based on the history of based on the EHR, which is electronic health record patient history, using the statistical rules, basically which shows that it basically shows how patients are similar to each other. So patient 101 is similar to patient 1 to 100, and based on the similarity, it can exactly say, yes, you can basically administer drug 2 to the patient 101, and it won't have any side effects. So to follow up, here are some particular references. The first part of references essentially talk about what Lindsay presented about NSG-LD and so on. And the second part is more about what I presented on predicting links and inferring new information from existing knowledge graph. In particular, we have two papers. One is the KB-learn, and another is the bidirectional sequence encoder. So one of them uses a statistical way of predicting links, missing information. And the other one uses slightly more complicated deep learning based system to do the same. And I would highly encourage all of you to go ahead and look at some of these references.
Thank you very much, Bhushan. I'd like to say thank you to ETSI and to the organizers for making the opportunity here. And the main point I'd like to make from the point of view of NEC is that it's very important to support standards which allow interoperability between different systems. And especially in the health issues case, it's very well known that between countries and between proprietary systems, the data is not easily, in all cases, shareable. And when mistakes happen in the health system, then they can be very dangerous. And that is maybe not so, not so a dangerous situation in smart cities, but in parking spaces and so on. But I do know that in some cities they installed let's say some smart parking which didn't work very well, and they had to pull it out again afterwards because too many people were fighting over the not available parking slots. So take care that you have interoperable and well-defined information sources. Thanks.
Thank you very much, Lindsay and Bhushan, for taking us through the presentation. I think we've probably just got time for one question today. And Lindsay, if I could ask you, is it difficult for research groups to contribute into the ETSI standards process?
So ETSI is very open, and there are a number of different routes into, let's say, making contributions to ETSI. The key thing is to discover where and also have your goal in mind. If you simply want to notify the standards community that some new technology exists, then there are things like workshops or news or email lists. That's a kind of drag and drop approach, and you don't hear very much afterwards usually. But if you want that your new technology is available to others and made into something with interoperability, then there is the route through the ISGs, that industry specification groups, which are deliberately made low threshold and easier for external researchers to come into. And then also there's the route through the technical committees, which are aimed at long-standing areas such as, well, for example, intelligent transport systems for vehicles or e-health and so on. So talk to ETSI staff members via emails, or discover the right chairman of the right groups, or come along to ETSI workshops and contact the people who are presenting different ideas here.
Good advice. Well, thank you very much, Lindsay and Bhushan, both of you, for the presentation. Now, we have many presentations, panels and interviews across this two-day event, and they will all be available to watch later on demand. Please stay with us for our next session, which is a panel discussion on how we can put Europe at the forefront of 6G research and innovation. Not to be missed. Goodbye for now.